In this video, we will be discussing net present value, or NPV, as a method of capital budgeting. Remember that capital budgeting is the process of evaluating potential fixed asset investments to decide which ones to accept and which to decline. Net present value relies on something that's called the time value of money, so let's make sure we understand that first. The time value of money is simply the idea that money that you have today is more valuable than an identical sum of money at some point in the future. To help you understand why, assume that I was to offer you $100,000 today or $100,000 in 3 years. Which option would you choose? It seems obvious that you would choose the $100,000 today. Why would you wait? But even if you didn't need the money now or didn't plan on spending it for 3 years, the $100,000 today is still more valuable. Why? Because this money could be invested and earn some rate of return. In fact, if we assume a 5% interest rate, the $100,000 payment in 3 years actually has a present value of approximately $86,384. Why? Because $86,384 could be invested at 5% interest and would grow to $100,000 in 3 years. We'll talk more about how to do the calculations later, but for now, just realize that a cash flow in the future is not worth as much as an identical cash flow in the present due to the time value of money. The capital budgeting method of net present value finds the present value of all future cash flows and then subtracts the cost of the initial investment. To use net present value, the company must select a minimum required rate of return they want to have on their investments. The required rate of return is often the cost of capital, which is the average interest rate that the business must pay to its lenders. Let's assume that a company is considering purchasing a piece of equipment that costs $100,000 and is expected to generate $25,000 in cash flows in each of the next 5 years. The company also has a required rate of return of 6%. Even though the cash flow is an even $25,000 per year, the 5 future cash flows are not considered equal to the company. Why? Because of the time value of money. Cash flows in later years, such as in years 4 or 5, are considered less valuable than cash flows in earlier years, such as in years 1, 2, or 3. Net present value converts all future cash flows into a dollar amount in today's dollars, so we must convert each of the 5 $25,000 cash flows into a present value that takes into consideration that the later year cash flows aren't as valuable as the earlier cash flows. There are many ways to calculate the present value, including spreadsheets, calculators, and formulas. But today we will be using the present value tables. What we want to do is to find a different present value factor for each cash flow based on the table. To use the table, we first need a year and an interest rate. We already said that the interest rate will be the 6% required rate of return on investments, and the year will range from 1 to 5 since there are 5 years of cash flows. The name of the table that we need is the present value of $1. This table assumes that cash flows happen at the end of the year, so that will also be our assumption. The rows of the table represent the number of periods, which we are considering years in our example, and the columns represent the interest rate, which we said was 6%. Looking at the 6% column, we need the first 5 years of table factors, which I have highlighted here. We'll copy these values down and bring them back into our problem. Now I have the cash flow set up in a table by year, and I have copied over the table factors that we just found. We can multiply the table factor by the associated cash flows to get the present value of each cash flow. Now I want you to notice something about these table factors. The values associated with the earlier years are larger decimals, 0.9434, 0.8900, whereas the values associated with the later years are smaller numbers, such as 0.7921 and 0.7473. This is because of the time value of money. The later cash flows should be discounted more than the more recent cash flows, which we see reflected in the values in the present value column. We can find the total present value by adding up all of the present values together, which gives us $105,310. We can find the net present value by taking the total present value and subtracting the cost of the investment. $105,310 minus $100,000 is equal to a $5,310 net present value. What does this value mean? It means that the investment is providing the company with $5,310 of positive cash flows when we consider the required 6% return, and they should therefore invest in this piece of equipment. Generally, the decision rule for net present value is to accept the investment if the net present value is positive, and to decline the investment if the net present value is negative. If the net present value is 0, That means that the investment has earned exactly the required rate of return. Now, there's a little bit easier way to calculate the net present value if the investment provides even cash flows each year, as ours does. The method I showed is the long way, which works for all problems when cash flow is either even or uneven. When cash flows are even, we call the stream of cash flows an annuity, which is defined as a set amount of cash paid at regular intervals. We can use the table titled The Present Value of an Annuity of $1 instead of the present value of $1. Our $25,000 cash payments are an example of an annuity because they happen once a year for 5 years, and it's the same amount each year. If the cash flows are even and you use this method, we only need to use one table factor instead of 5 as we did just a minute ago. Glancing at the present value of the annuity of $1 table, we see that it looks very similar to the present value of $1 table. We still have the number of periods, which will represent the number of years, as the rows, and we have the interest rate as the column. This time we only need to find one table factor instead of 5. We need the intersection of 6% and 5 years, which we see is right here, 4.2124. We can take the 4.2124 and multiply by the annuity payment of $25,000, which gives us $105,310. We could then subtract the initial investment of $100,000 to get the net present value of $5,310, which is the same value that we got earlier. Okay, now that we have talked about how to calculate net present value, let's look at the advantages and disadvantages of using it. First, for the advantages. Net present value reflects the time value of money, which generally makes it a more rigorous and accurate method than some of the other capital budgeting methods that we looked at that ignore the time value of money. Net present value also functions just fine when cash flows in a period switch from positive to negative, which we will see is not the case for the next capital budgeting method we will look at, the internal rate of return. For disadvantages, it can be difficult to compare investments of differing scales using net present value. For example, two projects both with a net present value of $2,000 shouldn't be judged as equal if one requires a $100,000 initial investment and the second only requires a $20,000 investment. The result of the net present value does not reflect the differences between these two investments. Also, a required rate of return must be determined to calculate net present value, which can sometimes be a difficult number to come up with. Okay, that wraps up our discussion of net present value. Join us in the next video for a discussion on the internal rate of return.